Hello, I'm Peter Boswell with the Atlantic Grains Council, and we're here today to do seed drill calibration with Steve Hamill of the PEI Department of Agriculture and Lands. Today's video is put together with funding supplied under the Canadian Agricultural Partnership Program, which is Agriculture and Agri-Food Canada, the provinces of Newfoundland, Labrador, New Brunswick, Nova Scotia, and Prince Edward Island. And with the support of our producer Chekhov, and a special thank you to our Chekhov partners and the producers from across Atlantic Canada that are supporting the work of the Atlantic Grains Council. With me, as I mentioned, is Steve Hamill. Hello, Steve. And,
Hi.
Go ahead.
Happy to be here today, Peter. We're just going to walk through the procedure to calibrate this grain drill so we can ensure we have accurate seeding rates when we head to the field. So will help reduce seed costs and give our crop the best start when we hit the field. We can go with confidence knowing that we have the right rate.
The information that's contained in today's video is also going to be available on the Atlantic Grain Council website, and we'll include a link to that site in this video. Steve?
Okay.
You mentioned to me the importance of calculating your seed rate before you actually get into the process of calibrating the drill. Do you want to just go through a little bit of that process?
Yeah, so you want to calculate based on the plant population, because when you seed in terms of a weight or volume per acre, you're not taking into account seed size. It can vary quite a bit from year to year, and also things such as seed treatments and seed inoculants will affect how the seed flows through the drill. So you want to pick a population and calibrate your drill based on that. Okay, so for today's demonstration, we're going to be seeding wheat, and if you look here, these are the recommended plant populations for cereals in Atlantic Canada. So between 375 to 450 seeds per meter square, which is 1.5 to 1.8 million seeds per acre. So the easy way to do this is, if you look at the seeds you're sowing, it'll say on the tag, so this year's 25R40 seeds, so it's 11,000 seeds per pound. So we're going to be targeting a rate of 1.7 million seeds per acre. So if you come to this chart, the seeding rate chart, and you come across the top axis to 1.7 million seeds per acre, or 425 seeds per meter squared, and down this vertical axis you have your seed size, which is given in 1,000 kernel weight, or the number of seeds per pound. So this lot is 11,000, so 10,008 left, so we're in here somewhere. So you follow this across and down. So we're going to be targeting a seeding rate of 177 pounds per acre. And this chart assumes a 95% germination and a 5% mortality rate. So we'll target 177 pounds per acre. All right, so now that we have our seeding rate determined, we're going to get ready to calibrate the drill. And to do that, there's a few tools you'll need. So first, you're going to need a hydraulic jack, or bottle jack, or floor jack works fine. Today we're going to be using this floor jack. You need fiberglass measuring tape, or regular measuring tape. We're going to need some containers and bags for seed collection, scale that will weigh in grams, and duct tape or some sort of tape and a marker that we can use to mark the drill so we can easily count the wheel revolutions. Okay, so I lowered the drill mechanism, the field position. So now we want to remove the hoses that we're going to do during the test. So we just pull off the hoses that we're going to do. We'll do four for for this particular test. So you want to make sure that the hoses are all clean and clear of obstruction. So if you want to blow compressed air or use a wire down there to make sure they're clean, that works well. Because especially when you take them out of storage, sometimes you can have cobwebs and stuff in there that cause seed blocks. So you want to make sure they're all free and clear. So the next thing we'll have to do is determine the row spacing of the drill. So you just take your tape measure and measure between the runs, and you'll see that these ones are 15 inches, but the front gang is offset with the back, so that means we'll have a 7.5 inch seed spacing on this drill. So the next thing we're going to do is to jack up the drive wheel so it can be freely spun by hand. So once it's high enough that you can freely move it by hand, we've got to take our fiberglass tape and figure out the circumference of the tire.
Let me give you a hand there, Steve.
Okay, we'll just put the tape under. Over the top. And we got 8 feet, 8 inches. There's 8 feet and 8 inches there. So the circumference is 8 feet, 8 inches. We'll use that to determine our strip length. The alternative method, if you don't have a tape like this, you can measure the diameter of the tire across and then times by pi, which would be 3.14. You get the same answer. The next thing we want to do is mark the tire with tape or a permanent marker so it can be easily counted as you're doing your revolutions. So, put a piece of tape there so you can easily count as we're doing the test. So now that we got all our measurements on our drill, we're ready to go ahead and start the calibration process. So I got this grain drill calibration sheet that I printed off the Atlantic Grains Council website, which gives a step-by-step of how to go through the procedure. So I'm just going to start filling that in here now. So the make of the drill is a John Deere 750. We counted the number of drill runs and there's 24. We previously determined that the row spacing was 7.5 inches, but we need that in feet. So 7.5 divided by 12 is a row spacing of 0.625 feet. So the total width of the drill will be A times B, which is 24 times 0.625. So our total drill width is 15 feet. The tire circumference we determined was 8 feet, 8 inches. So 8 divided 12 is 0.66. So our tire circumference is 8.67 feet. So the next thing we want to do is determine out how long a strip we're going to test. So I recommend doing a minimum of 100 feet. So we'll take 100 divided by 8.67 our circumference. So we need 11.5 turns, so we'll do 12. So 12 wheel rotations times 8.67 will give us a strip length of 104 feet. All right, so our next step in the process is we're going to determine how much seed we need to collect from each run in order to equal our target seeding rate. So our target seeding rate, as we previously determined from this chart, is 177 pounds per acre for this seed lot. So the quantity in grams that we'll need per row, we can calculate by these steps on this sheet. So we got to take D, which is the wheel circumference, so 8.67 multiplied by B, which is the row spacing, 0.625 feet, multiplied by E, which is the number of wheel turns we're going to do in the test, which is 12. So that's going to give us the square feet that we're going to cover in this test, which is 65. So we want 177 pounds per acre, which is G 177. And then we got to divide that by the mathematical constant for square feet in an acre, which is 43,560. So that's 0.264 pounds. which isn't very convenient for weighing, so I'm going to convert that to grams by multiplying by 454. So we need 119.9, so 120 grams essentially per row to equal 177 pounds. And we decided that we're going to test 4 rows. So in our 4 rows, we're going to need to collect 479 grams of seed to equal a seeding rate of 177 pounds. So the next step is head to the drill and perform the test. Okay, so now we're ready to perform the test. The best way to start is by opening your drill lid, or it could be in the operator's manual, but they have a chart. So you come along here for wheat, and we're looking for 177 pounds. So that's about 35. So we'll set the mechanism at 35, run the test and see how close we get. Okay, so now we're on the front side of the drill where the mechanism, we already loaded seed into the drill and spun the wheel to make sure there was seed flowing from all the tubes. So we want to set this handle to what the chart said. So it said 35. So when you're doing this, sometimes there's a lot of play in these, so you want to go past your number and back and then settle in where you want to be. So we want to be on 35. So we'll go past this and back and settle on 35. Now we'll put the bags on that we're going to use for collection. I like to use Ziploc bags that have so you don't have to use elastics or anything, but you can use cups. You can lay a tarp down, whatever works, but I find this to be the easiest. My bag's broke. So you also, when you're up here, you want to check that your seed cups are set for the appropriate sizes, which in this case, they're set on the lowest position for small grains, so that's where we'd want to be. So now we got to head to the back of the drill and spin the tire and collect the seed and weigh it off and see where we're at. Okay, so now we're going to rotate this drive wheel 12 times while collecting the seed and see where we're at. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We'll go away and do some math. Okay, so now we got our scale here. We'll turn it on. We got to make sure to zero out our container because we only want to weigh the seed. And then empty, where we're going for 120 grams per row, or 480 total. So we'll just dump it in here and weigh. So that one only had 87, so it appears that we're going to be light. So in the 4 bags, we ended up with 346 grams, and we were going for 480, so we're under our target seeding rate, but we'll do some math to to figure out what seeding rate this is actually at, so we know how much we should adjust the lever before doing it again. This calibration is trial and error, so you do the math and keep repeating the steps till you get in to a target of 2 to 3% is where I like to live with the seeding rate range. So we got to figure out the effective drill width, which is I, which is 4 times B, which is the row spacing of 0.625. So 4 times 0.625 is 2.5. We collected 346 grams of seed, so we want to convert that to pounds. So we'll multiply by 454. 346, we're going to divide by 454. So we collected 0.762 pounds. So we put it through the seeding rate formula. So K is 2.5 times F, which is the strip length is 104. So that was 260. So then we take our pounds. So we got 0.762 multiplied by 43,560 square feet in an acre and divide by the 260. So our current seeding rate is 128 pounds per acre. So we're light, so we're gonna have to open up our seed mechanism and try again until we get it within that 2 to 3% range. So since the seeding rate was less than we want, I'm going to open up this mechanism, reattach the bags, and perform the test again. So I opened it another 5 notches, so now we'll go and rerun the test to see what we have this time. So we perform the test again, weighing off the seed this time at our new setting. So this time we have 489 grams of seed. We were targeting 480, so we're a little high, but we'll run the math just to find out exactly where we're at. Okay, so on the second test, we collected 489 grams of seed. So we want to convert that to pounds. 489 divided by 454 is 1.077 pounds. So then we'll take that weight in pounds and multiply by 43,560 by 1.077 pounds. And then we're going to divide that by the 260, which we determined earlier, which is the effective drill width by the strip length. So that gives us a seeding rate of 180 pounds per acre. We were targeting 177, so we're within our 2 to 3%, so I think we'd be happy with that. As we were looking for, we can head to the field and we can seed with confidence. The last thing we'll have to do then is to lower the jack. And then we'll go around front and reattach the seed hoses. And the other thing to remember is this drill drives from both sides, so we'll have to go over and set that lever the same as this, so both sides of the drill so evenly. And then we should be ready to go to the field.
Well, Steve, we've concluded the shooting of the video. Do you have any final comments?
Yeah, just that the seeding rate couldn't vary slightly in the field due to travel speed, soil conditions, and overlapping. So it's just something to keep an eye on as planning progresses and make sure you're within that range that you want to be.
Well, on behalf of the Atlantic Range Council, Steve, I'd like to thank you and the PEI Department of Agriculture and Lands for your assistance in producing this video. I'd like to remind anybody that's watching that the information contained in this video is also available in printed form on the Atlantic Range Council website, along with the Excel spreadsheets that producers may find handy in doing the calculations. With that, I wish everybody a good day and safe farm.